we're going to look at some more indices, right? So this time we're going to kind of pick up a few oddities and some kind of problems, indices problems, particularly on Dr. Frost at the end, well, nearly the end. You're going to go off and do a task there where there are 8 questions which are tricky, and if you don't get them right, I want you to have a go. Have another go. Try and figure them out. Because they follow the basic rules every time, and certainly a lot of what I'm going to show you today, not these ones, you've already done these, but the ones I'm going to show you today would tie into those problems. Okay, these are definitely the kind of higher end of what we're going to get on those papers, but they are eminently doable. Really, by the end, once you've done a few of the tricky ones, you're going to look back at these early ones and go, "My God, these are so easy." Well, my goodness, these are so easy. I should say. I do apologise. Right. Anyway, here's a starter. I want you to simplify these fully, please. So press pause on the video and off you go. Okay, we have unpaused. Right, so when we've got a power raised to a power, we know that we multiply those two powers together. So this would simplify to be 8 to the power of 32. Here we've got 2a cubed, and we've got the whole thing raised to a power. Now, ordinary numbers, ordinary maths. You will need to do, I wouldn't necessarily usually write this step out, but you need to do 2 cubed, and we need to do, if I put this in a bracket, a cubed, cubed. Both bits need to get cubed, okay? So 2 cubed is 8, because 2 times 2 times 2, and then you multiply these two powers together, the same rule that we used for the first one, so a to the power of 9. 8a to the power of 9. Okay, multiply the powers together, so 8 times by a half will be 4, it's just half of 8. What about a to the power of 3, all raised to the power of a half? Remember what the half means? It means a root, doesn't it? So you multiply these together, 3 lots of a half is, now you could write this in 2 different ways. I would suggest that you stick to the fractions, because remember, fractions are your, that's right, friends. And I hope you said it just like that. A to the power of 3 over 2, or of course, you could have written it as a decimal, a to the power of 1.5. But the fraction is more useful, because remember what we did last time, where we used, if there was a negative, we did the reciprocal. The bottom number on the fraction is a root, and the top number is a power. Okay, here we've got the power of half again. Now, just like this second one we did, where the 2 was an ordinary number, so ordinary maths, 2 cubed, this will be 9 to the power of a half. That means the square root of 9, because anything to the power of a half is a square root. So that's 3. And then we're going to do a to the power of 4 times by the half is 2, because half of 4 is 2. So 3a squared. Last one, the power of half again. Okay, 25 again. It's going to be 25 to the power of a half, which means it's square rooted. So it's 5. And a to the power of 5 to the power of a half. Again, fractions are your friends. I would write this as a to the power of 5 over 2. You could, of course, write that as 5 times a to the power of 2.5. But really, the ones that I think are best for us, that we should be doing, would be these, because, they are just generally more useful. Where's my other one? There it is. Okay, I personally think those are better answers than those, even though you still get a tick for both. Right? Moving on. So, indices problems, adjusting a power. Let's get back to my blue pen and have a look. So, for example, I've got 8 cubed, but it wants me to write it as a single power of 2. Now, what that means is write it as 2 to the power of something, right? So 2 to the power of n, but that n needs to be a number. Now, what you're going to do is adjust this. First of all, let's write 8. Let's ignore the power of 3. Let's write 8 as a power of 2. Now, 8 is equal to 2 cubed, right? So we can rewrite our 8 to the power of 3, so 8 to the power of 3, can be written as 2 cubed, that is a 3, and then all of that is still cubed, isn't it? Because it's 8 cubed, so it's this, cubed. And of course, just like the starter, we know what we do with our powers here. If it's a power raised to another power, you multiply them. 3 times 3 is 9, so it's 2 to the power of 9. Right, so the sneaky bit here is that you just write this number, this base number, as the new base number, but with the power. Okay, so 8 was 2 to the power of 3, so just like that. All right, let's try another one. What about 25 to the power of 4 as a single power of 5? So they want us to rewrite 25 as a power of 5. Well, 25 is 5 squared, right? So that's equal to 25. And that needs to be to the power of 4. 25 to the power of 4. So we've got the right base number now. Now we just multiply our powers together using our normal rules. So 2 4s are 8. There it is. So if I'd started with my question written down, which I should do really, 25 to the power of 4 is the same as 5 to the power of 8. Next one, what about 27 to the power of half? Same thing again. 3 and 27. Well, 27 is the same as 3 cubed, right? So we'll put that in a bracket and we'll raise that to the original power, which is a half. So 3 times a half would be, well, just write it as a fraction, 3 over 2. You could write 1.5, but let's stick to the fractions, okay? Yeah, so you've written 27 to the power of half with a single power of 3, 3 to the power of 3 over 2. And let's think about that. What that would mean. That would be, well, anyway, it just does work, all right? Just trust me, it does work. Anyway, whatever, moving on. Distracted myself. There's 3 questions for you to have a go at. So 9 to the power of 5 is a single power of 3 and so on. Pause the video, unpause when you are done. Don't just skip this bit. It's so important that we have a go at these. Okay? Pause the video now. We have unpaused and the cookies are going in the oven. The cookies are going in the oven. I don't know if you can hear that in the background. There better be some gluten-free ones or I'll be very upset. 9 to the power of 5 is a single power of 3. Okay. Let's go. Right, so that would be 3 squared is the same as 9, isn't it? And we want 9 to the power of 5. Multiply the 2 powers together using our rules. 3 to the power of 10. Whee! Well done. I know you got that right, because you're great. 16 to the power of a third. So, to 1/3. That's the cube root of 16. Well, let's write 2 as a 16 is a power of 2. So 2, well, 2 times 2 is 4 times 8, 16. So 2 to the power of 4 is 16. And that is raised to the power of a third. That means, let's multiply these together. Just write it as a fraction. It's the easiest way of doing it. 4 times a third is the same as 4 over 3. 81 to the power of 4 is a single power of 3. So let's write my question out. And 3. Well, how many times do I have to times 3 by itself to get to 81? Well, 3 times 3 is 9, times 3 again is 27, times it by 3 again is 81. So that is also 3 to the power of 4. So that is 81. And I want to raise that to the power of 4. Well, that is 16. 3 to the power of 16. Okay, hope you got those right. Let's make it trickier. Let's always make it a little bit trickier. One little step at a time. One more step along the maths I go. One number as a power of another. I don't know where that came from. No idea. Okay, so after that, right. Here's what we're going to do. You're going to kind of take it down to the a common base power and then back up again. So what I mean by that is if you look at 8 and 4, 8 is a power of 2. Okay, 2 cubed is 8. 4 is also a power of 2, which is 2 squared. Right, so we're going to go from 4, we're going to sort of take that down to 2, and then back up to 8 again. All right, now if I want to go from 4 to 2, it's going to need to be to the power of a half. Yeah, because if I'm square rooting it, I'm square rooting the 4, which is the power of half, that takes it down to 2. Then to go from 2 to 8, I need to cube it, which means my powers must be a combination of these two things. So 8 is the same as 4 to the power of 3 over 2. I'm putting my half and my cube together, the power of a half and the power of 3 to make 3 over 2. So it is 4 to the power of 3 over 2. You take it down to that common base number and then back up again to the number you want. Yeah, so 4 to the power of 3 over 2. I'll show you another one. And it works with writing a big number as a power of a small number too, right? Okay, so these, again, to 4 and 8, we know they're both you know, they have a kind of common power of 2, don't they? 2 squared is 4, 2 cubed is 8. So I'm going to go from 8, I'm going to take it down to that sort of common base power of 2, and then back up to the 4. Right, how do I go from 8 down to 2? That's the cube root. I need to cube root 8, so that's a power of a third. And then I need to square it to the power of 2 to get up to 4. So I'm going to cube root to get to 2, and then square it again to get back up to 4. Which means 4 is the same as 8 to the power of, put these two powers together, 2 over a third. You're multiplying these two powers together to get 2/3. So you cube root it and then square it. Okay, let's try. Okay, so this time we've got 9 and 27. They both have a common base number of 3, don't they? Because 9 is the same as 3 squared. 27 is 3 cubed. Let's put that over here, why not? 9 equals 3 squared. 27 equals 3 cubed. Okay, so we're going to start with the number that we want to have the power of at the end there. So we start with that, 27. We're going to go down to 3 first of all, and then back up to the number that we want, the value we want, which is 9. Now, 27 is 3 cubed, so I need to cube root that to go down to the 3. And once I've got the 3, I'm going to square it, so that's the power of 2, to get up to 9. So, right, 9 equals 27 to the power of, multiply these two powers together to get 2/3. Yeah, so you cube root the 27 and then square it. Last one, opposites. Now, once you've got the answer to this one, actually, if you notice here, look, 4 to the power of 3 over 2 is the answer to this one. When it's reversed, the answer is the same power, but it's the blimey, my mind's gone completely blank there. You know, you flipped that fraction, haven't you? It's the reciprocal. This is the word I was struggling for there. And so this time, because the question's reversed, we'll also have the reciprocal. But let's go through the motions, right? Both of these have got the common base number of 3, haven't they? 27 is 3 cubed, 9 is 3 squared. Now we want the 9. So we are going to go from the 9, oops, scribble it out, down to that common base number, and then back up to the number we want, which is 27. Now 9 to 3, well, 9 is 3 squared, so I'm going to square root it to get to the 3, and then I'm going to cube it to get up to 27. So 27 is the same as 9 to the power of, multiply these two powers together, 3 over 2. Okay, so go down to that common base number and then back up again, and then, you know, write your number to that power, that combination of those two powers. As always, it's your turn. Quite a few to do here. Remember, just find that common base number, go down to that first, and then back up to the number you want. Pause the video, unpause when you're done. Well, done so quickly. You must have been working very hard. Let's unpause. Okay, right, 125 as a power of 25. So we want the 25, so we'll put that first. The common power here is 5, isn't it? 125 is 5 cubed, 25 is 5 squared. And we're going to go up to the number that we want, 125. Right, 25 to 5 is a great time, but it's also, you have to square root it. And then 5 up to the 125, you're going to cube it. So 125 could be written as 25 to the power of, put the half and the 3 together, multiply those two together to get 3 over 2, because 3 lots of a half is 3 halves, yeah? Same here, this time we're going to go from 125 is where I want to be. Oh, what is the number I want to have the power from, sorry. We'll go down to 5 and then back up to the number that we want. We want the value of 25. Well, I would have to cube root, so that's a power of a third. And then I'm going to square it to get back up to 25. So 25 is equal to 125 to the power of, put the third and the power of 2 together. That's the dog wanting to go out the cat flap. Our houses all go 2/3. Yeah, 125 to the power of 2/3. Right, 32 as a power of 4. Again, 4 is the one we want to have the power of. 2 is the common base number here. And we want to be getting to the value of 32. So 4 to 2. Also a great time. Not as good as what the other one was. Yeah, and we're going to square root it. So square root the 4 to get to get 2. Sorry, power of a half. Right, 2. What power of 2 is 32? Well, from the last video we had this loads. It's power of 5. 2 times 2 times 2 times 2 times 2. Which means 32 equals 4 to the power of, put these two together, 5 over 2. Yeah, we're writing 32 as a power of 4. 4 to the power of 5 2ths, or 5 halves. And let's do the other way around right then. So 32 is the power we want. Now we're going to go down to that common base number, which is 2, and then back up to the 4. I don't know if you can hear my dog running around the house like he's a horse. It's ridiculous. 32, right, so 32 is 2 to the power of 5. So you might get a bit stuck on this one, but if it's 2 to the power of 5, I need the 5th root. That means the power is 1/5. Yeah. And then once I've got to 2, I'm going to square it, so that's the power of 2, to get back up to 4. So 4 equals 32 to the power of a 5th and the 2. Put those two things together. 2/5. You basically do the 5th root of 32 and then times it by 2. Not times it by 2, power of 2, sorry. Starting to lose it a little bit. Right, 81, 27. So 27 is the one we want to power of, so that comes first. What's the common number here? It's 3. And then back up to 81. So 27, I need to cube root that. So that's 1/3. Cube root it. And then up to 81. That is the power of 4. Not the power of Grayskull, the power of 4. He-Man, look it up. It's an 80s cartoon classic. So that's 3 times 3 times 3 times 3. Right, 81 equals 27 to the power of, put those two things together, 4/3. Oh my god, the dog has actually lost it. I don't know if you can hear that, it's ridiculous. He loves maths, loves it so much. Lockdown is great fun, isn't it? Right, 27 is the power of 81. I'm not sure I can keep this together. 81 is the one we want to have the power of. The common number is 3 again, and we want to get back up to 27. So what do? It's 3 to the power of 4 is 81, so it's the 4th root. It's 1/4. And then we are going to cube it. That's the power of 3 to get back up to 27. Right, so put those two things together. 27 equals 81 to the power of 3 over 4. I do hope you can hear this, otherwise I just sound like an absolute idiot. Anyway, moving on, because this is more important. Try one at a time and mark as you go. Here's my plan. I'm going to show you one question. You need to pause and then unpause when you're done, or you've written something. Do have a go. Don't just ignore it. Don't go, I don't know what I'm doing. Have a go, please, and then just watch my instructions, right? But we're only going to do one at a time. There's 4 questions on this page, 4 on the next. Then you're going off to Dr. Frost, okay? Right, so first question, that one. So pause the video, unpause when you're done. Oh, and you're simplifying, okay? Okay, I'm presuming you have unpaused now. Right, what do you need to do here? You need to add your powers together. Remember, when we're multiplying like base numbers together, you add the 2 powers. Okay, well, I can't directly add these fractions as they are, so I need to think about, where's my pen gone? Where's my pen disappeared? What is going on? Oh no, it's still writing. That's good. It's a bit strange. 1/5 plus 2/3. Remember, you add the 2 powers when you're multiplying like this. Well, we're going to adjust our fractions. The 1/5 is the same as 3/15, and 2/3, if I times top and the bottom by 5, is the same as 10/15, which means it's 13/15. That's my power. Yes, you can have a weird fraction like that as a power. It's absolutely fine. All right. So same basic rules, just slightly harder numbers, yeah, I guess. Right, question 2 then. So pause again and unpause when you are done. Okay, I'm guessing you've unpaused. Right, root 3 as a single power of 3. So I want to go from 3 to root 3. Well, that's quite easy, really, isn't it? Because, oh, hang on, no, I'm going to to root 3. What am I doing here? I'm going mad. As a single power of 3, it's to a half, isn't it? That's not complicated at all. I don't know why I was looking at that like it was complicated. You know, root 3 is a single power of 3. It's 3 to the power of a half. Oh, silly. What about root 27 as a single power of 3, though? Right? Pause the video, write it down, and unpause when you're done. Back so soon, you must have unpaused. Right, here's what I would probably do for this one. I would first of all write 27, the square root of 27 is 27 to the power of a half. Yeah. Now, as a single power of 3, well, remember, we can write 3 cubed is the same as 27. But we want that to the power of half. This is just like the questions a couple of pages ago. And then we'll multiply our 2 powers together. So 3 to the power of 3 over 2. 3 to the power of 3 halves. Yeah. Number 4. Okay, pause again. Unpause when you're done. Right, here we go. Now remember, ordinary numbers, ordinary maths, but in this case, we can't do that. This is not 2 times 4/5. This is 2 and 4/5. So change it to an improper fraction first. Multiply the bottoms and add the tops. 2 times 5 is 10. Add the 4 is 14. So it's the same as 14/5. Then we're going to square it. Okay. Now remember, with our fractions, we said that it's the same as squaring the top, squaring the bottom. And that's because if you're squaring something, you're timesing it by itself. Multiplying fractions together, you multiply the tops, you multiply the bottoms. Now the bottom here is really easy because it's 25, because 5 squared. 14 squared is a little bit harder. That's 14 times 14, which I believe is 196. But I'm just going to double check that. And I could, of course, use all sorts of clever maths to do that, but frankly, I'm going to use my calculator. 196. Okay, and then, of course, you could simplify that back into a mixed number. Well, how many 25s go into 196? Well, it's 7. And 7 25s is 175, which means we have got 21 bits left over. So it's 21 25ths. 7 and 21 25ths. Okay, pretty straightforward those ones, weren't they? Next ones get a bit harder. Okay, again, one at a time. So there is a question for you. Think about how you're going to do that. Pause the video and unpause when you're done. The dog has now got a coconut. That's fine. Okay, pause. Yes? You've unpaused already. Okay, sorry, I shall get on with it then. Right, so 2n, right in the form of 2 to the power of something is what this means. When you've got it in this form, it means 2 to the power of something. Right, well, 8 is the same as, oh, sorry, root 8 is the same as 8 to the power of a half. We want it with the base number of 2. Well, 2 cubed is 8. And it's 8 to the power of a half. And then I'm going to use my standard rules for indices. When a power is raised to a power, you multiply the 2 powers. So 3 lots of a half is 3 over 2. It is now in the form of 2 to the power of something. And that's what this means here. It doesn't mean we need algebra in there. We just need to have 2 to the power of something. It's just another way of writing that question out. Okay, next one. Just going to tell you here, you're going to need to form up a little equation in a minute and solve it, okay? Right, pause, unpause when you're done. Okay, you must have unpaused. Right, there's a common base number here with 81, 9, and 3. All of them have got a common base number of 3, right? So 81 is the same as 3 to the power of 3, 9, 27, 81. 3 to the power of 4. 9 is the same as 3 squared. And that's to the power of x. That's 9 to the power of x. Yeah. And then I've got 3 to the power of 2x. Right. Now look at this. We can actually do a bit of simplifying here. Firstly, let's simplify this section in here. 3 squared to the power of x. Remember, when a power is raised to a power, you multiply your powers. So we can write it as, rewrite the whole thing, 3 to the power of 2x times by 3 to the power of 2x. Okay? Then we're going to simplify a little bit again, because we've got two like base numbers multiplied together. And remember, you add your powers. 2x plus 2x makes 4x. Now you can probably guess what on earth's going as the answer for the next bit here. We've got 3 to the power of 4 is the same as 3 to the power of 4 times something. Basically, these must be equal because it's the same base number here, and they're equal. So 4 must equal 4x, which means x must be 1. Yeah? So what you do here, the trick here, is to write it all as the same base number and then simplify and keep simplifying until you've got the same base numbers and the powers must be equal. In that case, either side of that equal sign. You set up a little equation and solve it. Now in this case, it's really easy because x was 1, but if you set up a little equation there and then solve, you'll always get the answer. Okay, so it's slightly gone over the question there, but I'm sure you'll cope. A to the power of a fifth times a to the power of 2/3 over a to the power of 3/5. Pause the video, unpause when you are done. Okay, you have unpaused. Right, we did kind of the top part of this question before, didn't we? You need to add the two powers together. So I'm going to add 1/5 and 2/3. And we already said if I'm adding a fifth and 2/3, that's the same as adding 3/15 and 10/15, which was 13/15. Okay, so we can rewrite our equation here just to save any confusion. I would like to change my pen color, but it doesn't want me to change my pen color, so I can't. Okay, should we put the answer up here? Little box, give ourselves a bit of space. So a to the power of 5 times by a to the power of 2/3. Add the two powers together. So a to the power of 13 over 15. And then we're dividing that by the bottom number on our fraction. So 3/5. What happens when you're dividing? Well, you subtract your powers. So this will be the same as a to the power of 13 over 15 subtract this power here, which from the question is 3/5. Okay, which is, let's get the denominators the same because otherwise we can't subtract our fractions. If we times the top and the bottom by 3, so 9 over 15, I've got 13/15, take away 9/15, which is 4/15. So this simplifies to a to the power of 4/15. We've had easier ones before without fractions, and it was pretty much always the same thing. Simplify the top first, and then you can do the fraction. You know, we're still basic rules on this one. It's still the early rules, just with fractions in there. Last one. This is a lot easier than it looks. There's my little hint. All right, pause the video, unpause when you're done. Okay, you've unpaused. So let's have a little look. Right, firstly, some stuff is going to cancel out here. Look, I've got the pi on top is going to cancel out the pi underneath because the whole top is multiplied together, the whole of the bottom's multiplied, so we can divide the top by pi, divide the bottom by pi, it instantly disappears. I can also do 50 divided by 2 is, let's open up that square root first of all, 50 divided by 2 is 25. And I can do a to the power of 7 divided by a to the power of 3. Remember, what happens to our powers? We subtract. 7 take away 3 is 4. Okay, now I've got the square root of this. Now, if you remember from our surds, if you've got two things multiplied together in a square root, you can separate them out. into two separate square roots multiplied together. Well, square root of 25 is 5, and square root of 4, we're going to halve that power to get a to the power of 2. 5a squared is what that simplifies to. Okay, see, I told you that was easier than it looked. Right, let's move on. Here you go. Right, here's your task to do. As always, it's not that one written in the bottom there. It's this one here. Indices problems higher. Don't know why there's no bracket there. That upsets me. And there are only, I think, 8 questions to do, but they do get quite tricky. They start off okay. They do get tricky, but they are very doable if you just stick to the rules and just, you know, maybe look back at what we've done here. But please don't skip them. Don't just get them all wrong instantly and go, see, I'm not doing it ever again. You know, have a good go through it and maybe try it again. Okay? Right. Off you go. But come back when you're done, unless you run out of time for the lesson, because there's another task just after this one. So pause the video, go do Dr. Frost, and come back when you're done, and we'll do the next task. Yes, Murphy. They've finished, have they? Thank you, Murphy. Is there a child stuck down a well? No. Right, that's a joke. Yes, thank you. Thank you. Too late. Here is a problem. So you've got a little pyramid here. We've done things like this before. The 2 bottom blocks go together. You do the product of those. Product means times. So you times these 2 together to fill up this block, and then these 2 blocks would fill up, multiply to make this one. So you've got to figure out what's going to go in this block and this block. Okay, so pause the video, do the pyramid, unpause when you're done. Okay, we have unpaused. Right, we are going to multiply these 2 together to make this one. So the base number is going to be 2, but what's the power? Well, these are going to be tricky to work with at the moment. I need to do equivalent fractions. So this would be the same base numbers, so 6, that's times the bottom by 2, times 3, sorry, times the top by 3. 3/6 is the same as a half. So now I can add my 2 powers together. It's just this rule up here, isn't it? This top one there. Add the 2 powers. 3/6 and 1/6 is 4/6. Okay, and if we were simplifying, I would also change that to 2. Oops, to 2 to the power of 2/3. Okay. So 2 to the power of 2/3. Now that's got to be multiplied by something to get to 1. Now a couple of ways you can think of this. Firstly, 1 is the same as 2 to the power of 0. So I need to have 2 to the power of 2/3 multiplied by 2 to the power of something, which is going to go to 0. Remember, we're adding our 2 powers. So 2/3 plus what equals 0. So, you know, 2/3 plus something equals 0. Well, that's going to be minus 2/3, right? You just take it away. Negative 2/3. The other way to think about this is that if you've got anything, let's say 5, if I times it by its reciprocal, 5 times by 1/5, that's 1, okay? So this is the reciprocal of this. Remember, the negative power is the reciprocal, isn't it? We haven't got that one written up there, but it's, yeah, so the same power, but just the minus. It's reciprocal. Now I've got to do 2 to the power of 1/6 times by something. So let's write this over here. 2 to the power of 1/6 times by 2 to the power of something equals 2 to the power of minus 2/3. What that means is, if we're multiplying, same rule as first rule of indices, we need to add together our 2 powers. So 1/6 plus something equals minus 2/3. Well, let's do our basic solving here. Let's take away 1/6 from both sides. So that's minus 2/3. Take away 1/6 will be the power I need. So that's minus 2/3. 1/6 isn't very good. We need to have the same base numbers, don't we? Oh, same denominators is what I'm trying to say there. Well, we can't have 2/3. Let's change that into sixths. That will be 4/6. Take away 1/6 is a total of minus 5/6. So my power is minus 5/6. Sorry, it was a bit of rubbish explanation, but Hopefully you followed. So negative 5, 6. Yeah, multiply those two together, you get this power. Multiply these two, you get this one. Multiply these two together, you get 1. Okay, tricky little problem, that one. But it's sort of stuff that can come up in an exam. So if you're not sure, I would maybe watch some of the earlier stuff or the middle of this video again. Otherwise, I hope you did okay on Dr. Frost. Do contact me if you've got any problems. But also, send me pictures of your work because I want to see how we're doing. Okay? All right, well done. I shall see you later. Bye-bye.